Jupiter has flung thousands of objects out of our solar system. That's what we like to believe it does. The protector, the shield. But here's the part that rarely gets mentioned. For every object Jupiter throws outward, it also sends another one inward. Right now, an interstellar visitor called 3I Atlas is approaching Jupiter at more than 60 kilometers per second. And something about this encounter is unsettling. Its trajectory isn't behaving the way we expect. Small forces we don't fully understand, are nudging it at the most gravitationally intense moment possible. If those forces align just right, Jupiter doesn't deflect 3I Atlas away from Earth. It points it toward us. So what if this visitor isn't just passing through? What if Jupiter's gravity is being used, intentionally or not, as a pivot point to turn it around? That question determines whether we're witnessing a close call, or the beginning of something we cannot stop. Jupiter has always been our protector. That's the story we've told ourselves for decades. The largest planet in the solar system. A gas giant with gravity so intense it bends light. Standing between Earth and the chaos beyond. Astronomers often describe Jupiter as Earth's bodyguard, a cosmic bouncer that catches or deflects asteroids and comets before they can reach the inner planets. It's a reassuring narrative. Jupiter shields us. Jupiter saves us. But in science, comforting stories are often incomplete. Because gravity doesn't protect. It doesn't choose sides. And it doesn't care what outcome we prefer. On October 7, 2023, astronomers confirmed something extraordinary. An object designated 3I Atlas became only the third verified interstellar object ever observed passing through our solar system. Not from the Kuiper Belt, not from the Oort cloud, but from another star system entirely. It entered at velocities no native solar system object could naturally achieve, carrying with it the mystery of whatever stellar neighborhood produced it. By all conventional understanding, 3I Atlas should behave like its predecessors, Oumuamua and 2I Borisov. It should pass through once and never return. Interstellar objects don't orbit our sun. They don't belong to our gravitational family. They are tourists, not residents. Except, something strange happened as 3I Atlas approached Jupiter. Trajectory calculations began to change. Not dramatically, not enough to make headlines, but enough to catch the attention of a small group of specialists who model orbital mechanics for a living. Tiny refinements, subtle adjustments, the kind that usually mean better data or better instruments. This time, though, some of those refinements pointed in an uncomfortable direction. They suggested that 3I Atlas might not be leaving as predictably as everyone assumed. Let's be absolutely clear. Jupiter did not shield us from every threat. In many cases, Jupiter delivered them. Consider comet Shoemaker-Levy 9. In 1994, astronomers watched as fragments of that comet slammed into Jupiter over 6 days. 21 impacts, each releasing energy equivalent to millions of megatons of TNT. What's often forgotten is this. Jupiter didn't heroically intercept something aimed at Earth. It tore that comet apart, locked it into an unstable orbit, and then collided with it. Jupiter created the threat, and then absorbed it. Then there are Jupiter family comets, objects that originated far from the Sun, but were gravitationally kicked inward by Jupiter itself. Every few years, one of them passes close to Earth. Most are small, most miss. But most is not all. Gravity doesn't have preferences. It doesn't protect Earth or endanger it. It simply follows geometry. Change an object's approach angle by a fraction of a degree, and you get a completely different outcome. One path sends an object out of the solar system. Another sends it toward the sun. And a very specific one sends it toward Earth. Jupiter isn't a shield. It's a tool. You'll often hear this phrase: 3I Atlas is on a hyperbolic trajectory. It's leaving for good. Hyperbolic gets used as if it means permanent, unstoppable, guaranteed. It doesn't. Hyperbolic simply means the object's velocity exceeds escape velocity at the moment we measure it. Reduce that velocity even slightly, and the trajectory changes. Not dramatically, not like slamming on the brakes, but subtly. Outgassing, solar radiation pressure, measurement uncertainty, tiny forces, almost invisible. But in space, tiny forces accumulate. And if 3I Atlas loses energy during its closest interaction with Jupiter, leaving forever becomes an assumption, not a law of nature. Spacecraft engineers understand this well. Fire your engines at the wrong time, and nothing happens. Fire them at the right moment, deep in a gravity well, and everything changes. This is why gravity assists work. A tiny burst of thrust at periapsis can be amplified into a massive trajectory shift. If 3I Atlas is venting gas, if its rotation isn't random, if Jupiter's tidal forces trigger internal pressure release, then a powered slingshot becomes physically possible. Not intelligent, not intentional, just physics aligning at exactly the wrong moment. Here's where scientists get uncomfortable. We don't know the exact spin state of 3I Atlas. We don't know its internal structure. We don't know its surface composition. We infer. We approximate. We model based on assumptions borrowed from other objects that may not apply. There are irregularities in its light curve, residuals in its trajectory. Could they be measurement artifacts? Yes. Could they indicate unusual rotation? Also yes. Physics doesn't care why an object is oriented a certain way. It only cares that it is. If orientation produces a specific outcome, that outcome happens, regardless of intent. When a near-Earth asteroid is discovered, information flows quickly. Observatories track it. Orbits get updated daily. Risk assessments are published openly. With 3I Atlas, things are quieter. Not because anyone is hiding anything, but because probabilities are low and data is incomplete. Still, silence creates space. And in that space, an uncomfortable question forms. If everything is fine, why aren't we hearing more? Let's be absolutely clear. This is speculation, a thought experiment. There is no evidence that 3I Atlas is under intelligent control. But thought experiments serve a purpose. Jupiter is the largest gravitational energy reservoir in the solar system after the Sun. If you want to change direction in space, you either burn fuel or you use a gravity well. Fuel is expensive. Gravity is free. A few hundred meters per second of delta V applied at the right moment could turn a flyby into a U-turn. That's not science fiction. That's orbital mechanics. Nature could produce this through coincidence, and intelligence could plan it. Distinguishing between the two from afar is nearly impossible. If 3I Atlas were to return, Several outcomes are possible. A distant miss, a close pass, or a collision. At over 60 kilometers per second, even an atmospheric grazing event would be catastrophic. And the warning time problem makes this worse. Fast objects from the outer solar system are faint until they're already close. Months, not years, of notice. That's not enough time to mount a meaningful defense. DART worked. It proved we can deflect a small asteroid if we see it early and it's moving slowly enough. But DART was designed for a very specific scenario. Change the speed, change the mass, reduce the warning time, and the solution breaks down. Our defenses are optimized for familiar threats. 3I Atlas is not familiar. None of this is alarmism. This is scientific humility. Our models work well until they don't. Edge cases expose limitations, and interstellar objects are, by definition, edge cases. Solar activity, outgassing, rotation. Small uncertainties compound over decades. And sometimes, that's enough to change everything. No impact trajectory is currently predicted. Let me repeat that. No impact trajectory is currently predicted. But the real question isn't whether Jupiter protects Earth. The question is this: which side of the knife's edge is 3I Atlas on right now? And if it tips, who or what is holding the knife? Stay with Ultimate Space Secrets as we continue to explore, analyze, and question the deeper mysteries unfolding beyond our planet, where physics still holds more questions than answers.